As I said before, very much welcome to everyone. It's great that you have signed up and you're here with us today. I hope you learn from this event today. And obviously, please feel free to ask any questions at the end and make it interactive. Okay. So today the event is about the real AI application in manufacturing. So it is part of the DIH World Community Days, and I will explain now what a DIH World is. But it's a series, of events organized by this European event. It's a large European project of 8.5 million euro, in which CeADAR is a partner. And CeADAR is obviously, powering, this event, is organizing this event. But these events, the community days, are happening during the last week in different countries in Europe. The idea with these events is just promote the project, the DIH World project. Also bring the SMEs in manufacturing closer to the DIHs, and I will explain what a DIH is, the Innovation Hub, so we can cooperate together, because we are here at the end of the day as DIHs to support SMEs and help them, uptake digital technologies. So I'm Ricardo Simón Carvajo, and I'm the head of innovation and development in CeADAR. And CeADAR is the Ireland Centre in Applied Artificial Intelligence and the Digital Innovation Hub in AI in Ireland. So you can see hashtag DIH World if you want to tweet, and please, include CeADAR in your tweets. So moving on then. We have me, okay, for 20 minutes or so, talking about the DIH World project. And I think you will be quite interested in that because there can be a lot of benefits for SMEs and DIHs. Then a keynote by Dr. Su, but I call her Sue, okay? She's the R&D manager at Dawn Farms. Dawn Farms is specialized in meat production, especially sausages. Then after that, we have our dear Edward McDonald, who is the director of CeADAR Center. He's going to talk about the services, about CeADAR, services in CeADAR, and also some examples of projects in the area of manufacturing where we have been applying artificial intelligence. Then we have no less than the CEO of Smart Factory. Smart Factory is an SME providing IoT and analytics solution for the manufacturing sector, so helping the manufacturing sector. And then after that, we have Professor Pekka Toivanen, our friends from Finland, who is one of the leading directors in DigiCenter NS, which is similar to CeADAR, DIH. They are specialized in artificial intelligence. So 30 minutes each, and after that, we have a round of Q&A, questions and answers there, and then networking. So after the questions, we are going to break out the rooms with the different speakers, and then you can join each room to ask specific questions there in a petit comité style, okay? And then we'll close at 11:50. So first of all, who are we, CeADAR? So CeADAR is, as I said, is the DIH, the Digital Innovation Hub in Artificial Intelligence. Very briefly, we are in two universities, UCD, which is the largest university in Ireland, and also TU Dublin, which is the largest technological university in Ireland as well. And even though we are in these two universities, we are funded by Enterprise Ireland and IDA, which are the two main agencies, governmental agencies, which promote assistance or help to the industrial area in Ireland, okay, or the industry sector in Ireland. So the thing is, they are paying us, okay, they are funding us to help SMEs, even though we are in the university. So we do applied research for the benefit of SMEs. That's what a Digital Innovation Hub does. So these are some of the services that the Digital Innovation Hub has to take. Provide services to industry, particularly SMEs, to help grow. Access to competence centers, different disciplines, R&D and technology development, of course, from prototypes to products. And Edward will cover, most of these services on how we provide them later. Access to infrastructure, which is key now, test before invest, to minimize the risk of SMEs in investing in a particular product or solution. Development of innovation ecosystem, we do it very well. We are actually the organizers of the European Data Science Awards. Brokerage, we do it a lot. Access to finance, from public, finance in Ireland to Europe. Market intelligence, we do it in artificial intelligence. And then training and education, which is very key now in Europe. And we have our training programs for our SMEs. And then finally, incubator services. We incubate, SMEs in CeADAR. Okay, and Edward will cover that later on. So I'm not going to waste more time on this. I'm just going to say that we have been awarded different labels, or like such as the BDVA iSpace Gold. The BDVA is the Big Data Value Association, which is the most prominent, one of the most prominent associations in Europe in the area of big data and AI, and they have this AI space label. So we have been awarded the maximum category, the gold one, which basically says that we are a digital innovation hub, because an AI space at the DIH is more or less a synonym. We are very proud of that. We got it this year. And also, around 2 years ago, we were selected as the top 30, after many applications, top 30 DIHs in artificial intelligence in Europe. That was an initiative by the European Commission to help identify key DIHs in AI across Europe, and also to promote collaboration to set or to pave the way to the new kind of initiative, which is being run now by the European Commission as well, which is to identify European digital innovation hubs, which are basically digital innovation hubs which are representative of a region and support other DIHs in that region. So Edward can tell you more about that as well. So moving on, DIH work. I'm going to tell you about the DIH work and which CeADAR is a partner, and also a Smart Factory with Brendan there. So the DIH World project, it's as I said, it's an 8.5 million euro project, and the idea is the goal is to digitize and transform the European industry and services, specifically manufacturing, the manufacturing sector, through digital innovation hubs, or through just powering digital innovation hubs and platforms. The project started on the 1st of July 2020, very, very recently, and will last for another 3 years. It's part of the Horizon 2020 project, okay? So the main objective is to accelerate the uptake of advanced digital technologies by the European manufacturers, SMEs in all sectors. So that's very important. This project is here to help SMEs using all of these technologies, from AI, to big data, to any other thing to do with, for example, 3D printing, anything to do with technologies for the manufacturing sector. Okay, and the idea is that because digital innovation hubs are these kind of hybrid centers which are between research and commercial aspects or industry, that we create a huge ecosystem there. Okay, we link all the DIHs in Europe to be stronger, to have a synergetic action, to share lessons learned, so we are better prepared when we are helping manufacturers. So we are supporting manufacturers in any other way with projects, or just by them or help them scale in Europe. Who we are. All of these partners here, CARSA, PW, Improve Academy, Novale, Jurada, and CBT, they are coordinating the project, with the main coordinator being CARSA, okay, which is a consultancy firm specialized in European projects, specialized as well in coordinating projects in the area of digital innovation hubs, and also has expertise in manufacturing. So he's a key, he's a key member there, and he has a lot of experience in the key areas of the project. And then all of these partners are supported. These other partners, which are also partners, they have digital innovation hubs like CeADAR. So in the project, there are 27 digital innovation hubs in 26 countries, you see now. And then also we have 8 SMEs, such as Brendan within Smart Factory, which are actually supporting 8 pilot experiments, which I explained what they are. But this is how the DIH network looks like. 27 DIHs, okay? CeADAR is here, and then, for example, our friends in Finland who's going to speak today are right here, okay? But lots of them well distributed, covering most of Europe. So the key concepts there of the project are based on these main 4 pillars, let's say. First of all, we're 27 at the moment, 27 DIHs, but the idea is, with all the activities, networking, and the experiments, we'll go to 70 DIHs. It could be even more in the future, okay? Because we are creating this kind of association of DIHs for the benefit of collaborating and learning, and then being stronger, as I was saying, to deliver a good service to the manufacturing sector. Then the idea is that the project will create, and is creating, has already started to create, this DIH World Academy. So this academy I'll go deeper later, but it's basically to provide training to DIHs in how to actually approach, for example, companies, in how to deal, with problems, in how to increase their services and all of that. It will be a directional way, but it's just to support training, particularly, to provide training, particular to DIHs which are new in this sector. For example, CeADAR is quite well established. We work in many sectors, but other DIHs are new enough, okay? So this training will be very much, welcome by them. And then the other two pillars are basically the open calls. So there's a lot of money provision, big budget provision to help experiments, so particularly SMEs with DIHs. There's two open calls, one in 2021, another one in 2022, and I will cover this now. But particularly the idea is that there's 8 initial experiments, and then after that, based on the lessons learned, 45 new experiments will be funded. So the DIH Academy. The DIH Academy, as I was saying, it tries to accelerate the matureness of these digital innovation hubs. And the main goal is to help each of the DIHs, depends on how mature they are, create a sustainable business model, particularly in the manufacturing sector. Okay, so how to interact, with the manufacturing companies, identify the needs of manufacturing companies, pivot, and things like that. Also, the other objectives, obviously, is knowledge transfer from the experts in the consortium. And the idea is that people like us go there, we have a lot of knowledge. For example, CeADAR, we participate in different events, but also we receive a lot of knowledge from them, and it's quite valuable just to see how they do it in Finland or in Spain, okay, and to adapt here in Ireland. And obviously international collaboration, because that's the future now. All the DIHs in different sectors, different projects, they are coming together to collaborate and just to see if they can offer services which are more integrated, okay, geographical particular area, okay, or in a particular technology or vertical. So the DIH Academy, as I said, there was a kickoff. We are working on the individual business plans, but there is a lot of training camps, okay, dissemination workshops, individualized remote coaching, and then webinars and online learning portal has been prepared and it will be updated to the project. So there is a great, set of tools here to support new DIHs and even existing DIHs. And then the most important thing here, the most important thing for SMEs and DIHs in the next kind of month will be the experiments and the upcoming calls. So, as I said, we have conducted, over the last 6 months or so, 8 experiments, which involve 8 SMEs and 7 DIHs. One of the experiments was in Ireland, okay, then, for example, in Cyprus, Finland, Hungary, Norway, and Spain as well. In Ireland, it was CeADAR with Brendan there with the Smart Factory. And then we did it, in the area of food production, okay. Other, DIHs and other SMEs we do it in wood and construction and the maritime sector. And obviously using different technologies, as I was mentioning before, from artificial intelligence to, for example, set weight with sensors, big data collection, deep reinforcement learning that we use, advanced manufacturing, additive manufacturing, loads of technologies there, okay. So the idea is that, these 8 experiments, we're serving as a pilot experiment for the first 6 months. We learn different lessons there that we are going to apply now in the open calls, okay, to fund more experiments. So new DIHs and new SMEs will apply for funding, and then 25 experiments will be selected in the first open call. After that, there will be another call next year, and then another 20 experiments will be selected. Up to a total of 53 experiments. So DIH World will support 53 experiments in which DIHs collaborate closely with SMEs in the area of manufacturing. So obviously the kind of experiments for the first open call, the one that is going to open soon, will be to integrate digital technologies, like always. So the DIH will help improve the processes, the products, or the services of these SMEs, and work closely with them. And the sectors are wood products, construction, and maritime. Okay, so you can apply on these areas. As I said, there's a lot of technologies. I'm not going to go through all of that, but you can see there smart modeling, Internet of Things, cybersecurity, cyber physical systems, 3D printing, high performance computing, many things there. Okay, maybe probably end it here. Then the key dates. The launch of the call will be next month on the 3rd of May. Be aware of that. You can register to the DIH World in the DIH World website to the newsletter. The deadline to submit the applications will be in July, and then after that, the evaluation will conclude in April, and the project will start in October for 6 months. So you might wonder what's in it, for the SMEs and the DIHs. First of all, €95,000 to be divided, between the DIH and the SME to conduct a 6 month experiment. And obviously for the SMEs, they have the chance to integrate digital technologies in their offering. For example, Brendan was, well, he's going to talk about that, but we were helping with machine learning and analytics to integrate this functionality in his offering. And also for the DIH, get access to all of this DIH network, collaborate with us, and learn through the DIH Academy, and obviously collaborate with an SME. So it's great value in applying for these experiments. As I said, there will be one here, the first open call, and then the second open call in 2022. Okay, and then 6 months here of execution. And finally, the community days, like the day today, they are events, there's 20 events across Europe being running in parallel or during the last week. The topic of 2021 has been Industry 4.0, and the idea is what it says there. It's just to break the ice between the SMEs and the digital innovation hubs, and just start collaborating and cooperating. And also, SMEs, many of them, they are not aware of how digital innovation hubs work, or even what a digital innovation hub is. So we have to keep on promoting this because there's a lot of benefits and a lot of funding as well to be leveraged at national and European level that we can help with. There will be, these are the first community days. There will be some second community days in 2022 and other in 2023. Okay. So thank you very much. I'm gonna now play a video which wraps up the DIH World project. So let me stop sharing and gives you a very nice condensed view of what the project is, even though I've mentioned a few things already. Here it is. 1 second. Let me see if you can see. You can see this, right? I'll play now. Right.
Digital transformation involves the integration of digital technologies into all areas of a business, from processes to products and services. The digital transformation process implies a fundamental change in how businesses operate and deliver value to their customers. Digitalization enables businesses to be competitive, increase profits, be more agile, improve productivity, increase visibility, be environmentally sustainable, and better respond to customer needs. Digital Innovation Hubs, DIHs, are regional one-stop shops that help companies, SMEs in particular, and public organizations to adopt digital technologies to improve their processes, products and/or services and become more competitive. The European Commission launched the DIH World project to accelerate the uptake of advanced digital technologies by European manufacturing SMEs. The project is therefore accelerating the growth of DIH maturity to enhance their ability to help companies grow, compete and reach global markets. DIH World is being delivered by a powerful consortium that brings together a wealth of knowledge, resources, technical abilities and dissemination capability. The project is coordinated by CASA and is supported by PwC, Improve, Innovalia Association, CeADAR, and CBT. The DIH World community currently features 27 DIHs from 26 European countries, as well as 8 SMEs from 6 countries that are developing 8 pilot experiments. The aim is to grow the community to include more than 70 DIHs and 50 SMEs. To reach this goal, DIH World will launch 2 open calls for consortium seeking innovative experiments conducted by 1 SME and 1 DIH. DIH World Digital Innovation Hubs are organizing events all over Europe to present their activities and services to SMEs, mid-caps and regional stakeholders. This first batch of community days in April 2021 is focused on Industry 4.0, automation and data exchange in manufacturing technologies. Participants will gain access to more information on Industry 4.0, international DI experiences, best practices across Europe. Be digital. Join the DIH World community.
Okay, very good. Let's wrap up what I said, and I think you have got a good idea of the DIH work project at this stage, right? I hope you do. You can ask questions at the end. So now I'm gonna pass on, to Sue. Thanks, Sue. So whenever you want, the screen is yours.
Okay, thank you, Ricardo. Let me share.
Mhm.
Okay, let me know if you can see my screen.
Yeah.
Great. Okay, so I'll get started. So thank you, Ricardo, for that introduction. Just to introduce myself, I'm Sue Saul, R&D manager at Dawn Farms. I was quite puzzled when Ricardo first wanted me to present at this community day event because I'm a food scientist by training, food chemist. I am no expert in AI or Industry 4.0. But Ricardo did clarify that he wanted me to talk about the challenges that we are facing as a food manufacturer. Food manufacturer trying to bring in these technologies to our business. And I concluded that, yes, I have a lot to say about the topic, especially talking from my experience. But to start off, I'm going to tell you a little bit about our business first. So Dawn Farms, we are based in the Republic of Ireland. We are the leading European supplier of multi-species cooked and fermented protein ingredients to the food service and manufacturing sectors. That implies that we're a B2B business, and what we mean by cooked and fermented protein ingredients, that can include what you can see in the picture, which is our drying rooms. Those are hanged pepperonis. We have salamis as well. We also do cooked, chicken breast, cooked beef, sous vide cooked protein ingredients. We also do plant-based proteins, so we do meat analogs for all of those as well. So that is our business. We have currently 4 dedicated plants, 2 in Ireland, 1 in the UK, and 1 in Germany. Our business headquarters are in Naas, which is also the location where I'm seated right now. And that's where we have our team in science and innovation. And our team is comprised of around 25 highly skilled technical experts, multidisciplinary, but mostly focusing around food science, food engineering, nutrition, and culinary. Our focus is around the industrial scale food production applications. Our current ambition at the moment and focus is to use recent advances in digital technology, IIoT sensors, and machine learning and other Industry 4.0 related technologies to improve, to innovate, and to pioneer in our areas of expertise, which I mentioned is really the food manufacturing in a large-scale production environment. These technologies currently enable for us to deliver improved resilience and lower operating costs through continuous improvement and optimization of processes within the food and manufacturing environment. And we are still on that journey. Our current focus is to improve some key operational metrics and also sustainability metrics. We are hoping to build on those capabilities to innovate at an accelerated pace. Given this, our next goal will be to use recent advances in these digital technologies to focus and optimize our production lines, and then integrate advanced robotics and other technologies in order to enable innovation. The autonomous manufacturing, we are hoping that will be brought in will help Dawn Farms to experiment with new transformative technologies and aggressively pursue innovation leading to sustainability-driven growth. And ultimately, by exploring the next advances and pushing the boundaries, we are hoping to pioneer in the area of protein science, food manufacturing. So this is a little bit about our journey towards Industry 4.0. And you'll hear a lot from the technical experts in this area. These stages in Industry 4.0 development path is something that was shown to me initially by Brandon, who will be speaking later from Smart Factory. And I would say a lot of other, well, not a lot of other, but a lot of food manufacturing businesses are in this journey, and they typically are situated at stage 3, which means seeing what is happening, so real-time monitoring of the production lines, and stage 4, understanding why it is happening through data analytics. And our current journey, and in terms of timeline of where we want to be within the next 3 years, is to reach stage 5. So preparing for what will happen. So knowing, predicting what will happen based on what's currently happening on the production line. And hopefully following that will be the stage 6, where we'll be able to self-optimize through autonomous robotics and feedback to our manufacturing lines. So I'm going to talk a little bit about our industry if you're not familiar, and our challenges and the goals that we have set for ourselves as a food manufacturer. And I'm talking for my team, comprised of food scientists and engineers. And from my background as a food product developer, my focus has always been for the last 3 to 5 years to deliver faster product, deliver faster innovation. New product development in the food industry is very time consuming. Especially with the increase in consumer demands around transparency, health, sustainability, and new flavors. For your information, a typical launch cycle of a product in our industry is around 2 to 3 months. And given this, companies are innovating faster to stay ahead, but with the added challenge of incorporating innovative ingredients for better health. These days, a lot of companies are trying to incorporate immune supporting ingredients. So that will be the type of challenge that we'll be facing. Also, sustainable practice in terms of the origin of the ingredients and the sourcing of the ingredients, and how our operations are as sustainable as possible. So, food product formulation is becoming much more challenging. And we've concluded early on that for us to respond to these market needs and grow with a competitive edge, we need to leverage every possible advances in technology. And this has been a journey for a lot of food manufacturers. I think starting back maybe 5 years ago, some meat companies have started using predictive modeling and AI to tackle certain challenges. At the beginning was bringing in sensor solutions, predictive models for, of course, better efficiency and quality monitoring of their production. More recently, a lot of different companies are focusing on product design and then product sensory quality and predictions of those for faster formulation for the customers and end users. Of course, we want to integrate all of these at Dawn Farms as well. At the moment, we're collecting and we are hoping to collect more data points to deliver our vision, which is more of a complete integration of the manufacturing process, where the end product sensory quality, machine sensing, or material behavior change during processing, production metrics, and sustainability metrics all come together for a holistic approach to new product development. Large-scale food processors with modularity and customization like Dawn Farms, we face many uncertainties around how the material will behave during different types of processing. If you take one material that is exactly the same but go through, either sous vide cooking or grilling or roasting, they end up tasting very different. So how do you put metrics around that, and how do you predict the end quality? We're hoping that these technologies will deliver the data analytics around raw material variations, processing variables, product sensory quality during new product development cycle to de-risk projects. And what a lot of companies are talking about, which is to get it right the first time, or to fail fast instead, but in a more sustainable and cost-effective way. In our industry environment, to be honest, a lot of time is spent on mitigating risks, and mitigating risks in silos within the company, rather than focusing on collaborative innovation. And from my experience, these types of projects really opened for a collaboration within the organization, involving different departments, pulling data, collecting data, and then hoping to build a continuous loop of reinforcement learnings, hopefully at the end to build predictive models that self-improves, to blur the lines between the different departments, from my department to operations, to technical, leading to total integration of the product life cycle, and really to create a new space for collaboration and new forms of innovation. Of course, it's great to talk about these potentials and ambitions, but this is a continuous journey for us, and there have been many hurdles. And the challenges that we are facing as a food manufacturer for greater application of these technologies, from what I heard and from what I've seen, is not very different from other businesses. The most important challenge was around building an understanding around what advanced data analytics, predictions, IIoT sensors, automation that can deliver for our business. There were many misconceptions around these technologies. AI is out of reach. This will take away jobs. This is not for our industry. It was difficult to start discussions initially why these technologies were needed, first of all. But I think this is a journey that most businesses have to go through at some extent, especially at the moment with the changes brought by COVID-19. Trying to do things differently, and to be open to new approaches when the tried and true path already exists. It's a continuous challenge in our journey, and our team is doing everything that we can to bring the entire organization on board, and that they are fully involved and excited about the potential. Another challenge that we are facing is the difficulty in identifying the concrete business outcomes to justify the investment and the risks. And I think there was a question from the audience about experiments. And I think, you can define our challenge of identifying those experiments, but those experiments need to deliver of course, the return on investment, obviously, but also deliver much more than that. And from our many discussions within the company, we knew that collecting data and advanced data analytics, putting on sensors on our lines, and to be able to monitor real time will be a positive thing for our business. But putting numbers to understand the monetary value of such initiative was an interesting exercise. And through a series of workshops within the organization, we were able to point to the right metrics that will deliver immediate benefits. And from that on, we were to justify for other projects as well that followed. And at the end, we were hoping to bring our whole company and our many production lines, not only in Ireland, but in UK and in Germany as well, through this journey. The other challenge that we had was around not knowing where to start, really. What are the service providers in this area? Who to work with? And that was really stemming from I would say the following challenge listed there, which is the lack of expertise. Of course, being 40 years in the food manufacturing, we have great expertise in knowing, what kind of data that could be useful for us, what would be good data, bad data, those type of things. But we had no idea, who would be help us, who would be willing to help us to bring in different sensors, connect those sensors, pull those sensors, the data through historians and gateways, and all of those. That was very new for us. So these are the main hurdles once we had identified the right business case. And this is, I think, how my presentation ties into the Digital Innovation Hub World Community Day. We at Dawn Farms, we are very thankful for the different support systems that are helping us to overcome the previously mentioned challenges. Of course, the different funding mechanisms at local and European levels are important to de-risk our projects around this area. But as I mentioned, the expertise and network building, it's very hard to achieve without, having resources and help from digital innovation hubs like CeADAR. And this has been crucial for us in our journey to help us tackle the challenges around AI deployment, education, training, network building, and in overall to facilitate the uptake of new and relevant technologies that are applicable for our business. I hope that my brief presentation was able to provide you with a glimpse of yet another company trying to move through the different initiatives to bring AI to their production floors. And as I mentioned, our needs and challenges mirror many other companies, not only in the manufacturing sectors, but just businesses, that are trying to become digital. And for us, it has been very clear that digital innovation hubs can help us achieve our goals faster. So thank you very much.
Thanks to you, Sue. Very nice presentation there. And I promise the audience, I haven't paid Sue to say these kind of words about CeADAR. The reality is that I think, it is true. Manufacturing companies, sometimes they are lost, in how to, for example, start in the area of the digital adoption there, for example, IoTs or AIs. And it is true that, data innovation hubs can really help there because, we are, at the end of the day, we are these, kind of entities funded by the government to do that. So we are not biased in any way there, and we are here to support you. So that's very good. You're saying that we have a project that hopefully will be funded soon, and we will start collaborating. So one of the things that I would say is just I'm gonna ask a quick question, and then if somebody wants to ask any other question, there is just from your. You just put some challenges there, but what do you think? It will be the main challenge if we or when you are trying to deploy a real solution, for example, in the production line itself there, whether it's AI or it's the sensors or whatever, do you think, there will be a main challenge there or a main barrier? Because obviously, it's just real deployment. It's not simulation or it's not just maybe applying,
I think the real challenge is for us to provide the right kind of education and training to our operations, the people on the lines, because they have a certain way of doing things, and to go from a reactive culture to this type of culture, when you get instant information and maybe predictive information, it's a whole culture change, and the operator may not even want to take on that journey because they know from experience what will work and what would not work. So I think that's going to be a main challenge if we were to get everything right in terms of technology.
Yeah, I agree. Let's see. Okay, so any other questions for Sue? Obviously, you have another opportunity to do it at the end if you are thinking now. So, any questions there? Do you have any questions? Let me see. Right now, don't be shy. Now it's just the perfect opportunity to have him here. Obviously, you can email her privately if you want as well, or chat it here in the Zoom chat. Okay, so fine. Let's leave them for the end. Okay, so now we're moving on. So thank you very much again, Sue. I have to learn, how to do these things, putting your face here on one side and the floating slide here. It looks fantastic, not like me there. But anyway, thank you very much.
No, thank you.
Thank you very much. Thank you very much. So we're moving on now to Edward Mcdonald. For those who don't know who he is, he's the director of CeADAR. The best center in the world, I would say, but I cannot say these things. So whenever you want, Edward, the screen is yours now.
Thank you very much, Ricardo. And I never believe what you say anyway. So thank you. There you are. So hopefully, has that come through for everybody? Can you see a full screen? Great. Well, again, I'm delighted to have the opportunity to talk today briefly just about the role of digital innovation hubs, and also just to give you an appreciation at a very high level of some of the work that we're doing in the whole realm of Industry 4.0. And as CeADAR, we're absolutely delighted to be part of DIH World, and obviously that was something that was very much spearheaded by Ricardo, and we're delighted to be part of the community in that. So, as Ricardo mentioned, I'm Edward McDonald, the Centre Director of CeADAR, which is Ireland's digital innovation hub for applied AI, and we do acknowledge the funding of our sponsors, Enterprise Ireland and the EDA. Now, the next challenge is getting me to move on. Now, Ricardo did mention about the community of digital innovation hubs across Europe, and I just wanted to re-emphasize that it's part of the initiative by the European Commission under the new Horizon Europe program, which is the successor to Horizon 2020. And we will have these digital innovation hubs distributed across Europe, basically as centers of excellence and help for the SMEs, particularly in public service organizations, and obviously not forgetting the multinationals, but the focus is very much on the mid-cap and smaller companies and public service organizations. 2 years ago now, the Commission launched a call for these digital innovation hubs in AI, and the competitive process, and CeADAR was selected as the nominated digital innovation hub for AI in Ireland. There's also an organization, it's a public-private partnership existing in Europe. It used to be called the BDVA, the Big Data Value Association, but recently it has merged with another European Commission public-private partnership, the robotics one, to actually form an organization now called DAIRO, D-A-I-R-O, that's Data, AI, and Robotics. And basically, it represents all the major players in Europe in those areas. And we are one of the 9 gold iSpace innovation spaces, which are roughly equivalent to the digital innovation hubs across Europe. And again, it's a network, a community of organizations, because we are stronger together. And one of the objectives of this community is that we share best practice, we share knowledge, we share expertise. So if there's areas that we can't address, then we can reach out to these other digital innovation hubs across Europe to fill those gaps, and vice versa as well. So this new arrangement, which we were elected to this Gold iSpace in November 2020, and we are looking forward very much to actually a closer relationship with all these other hubs around Europe. And of course, as part of the existing DIH World and Horizon 2020 as well, we work in collaboration with a lot of these other centers, so stronger together. The final thing to mention as well, as part of the whole European initiative, we co-founded in 2015, along with a company called Next Generation here in Dublin, the European Data Science and AI Awards. And really, what that is meant to do is to showcase European excellence in AI, and basically to celebrate the successes of that. And the European Data Science and AI Awards have gone from strength to strength, and they are now supported, I'm delighted to say, by the European Commission as well. So that's a little bit of the higher level background. If we bring it back now down to the Digital Innovation Hub in Ireland, CeADAR has been in existence now for 8 years. And as of today, we've got 90 member companies. And I think one thing you'll see from all those logos there is really the diversity of the companies that are part of the Digital Innovation Hub. You can see there we've got companies in agriculture, we've got companies in food, in finance, in satellite observation, in consumer-facing applications. So again, it reinforces the ubiquity really of AI and data analytics and its applicability across every single industry vertical that there is. Now, in terms of CeADAR, so we see ourselves, and this is our value prop, as being a one-stop shop for innovation and applied R&D, really to deliver value to this community of companies to build their capacity in AI and analytics, and really to deliver to them in their products and services sustained competitive advantage. So not only to these member companies, but we also have a mandate to reach out to the wider ecosystem in Ireland as well. So in terms of the technologies that CeADAR operates in, we're definitely multifaceted. Every aspect that you can imagine that is in the AI armory, the different types of machine learning, the Internet of Things, distributed sensors, the visualization of data, blockchain in the supply chain, explainable AI, a very fundamental part of trustworthy AI is being able to explain the decision process that the AI has taken in achieving a particular outcome or conclusion. One of the areas that is increasingly important at the moment, and particularly in Industry 4.0, is computer vision and image analytics. And believe it or not, text analytics as well. I'll talk a little bit about that later. We're seeing that becoming more important actually in very heavily document-based industries like law, for instance, and also in processes in Industry 4.0. So the little diagram on the right-hand side with all the circulating sectors shows the main areas of work. And as I said, CeADAR works across a great variety of industry verticals. But these are the ones that we, at the moment, are getting most pull from the market in. So starting off there, if you see at the very top, Earth observation or satellite data. So that's very important, particularly in agriculture and in insurance cases and disaster recovery. Drones, now the unmanned aerial vehicles, that's UAVs. That is an area that is becoming extremely hot at the moment across a lot of verticals. Agriculture, the environment, the food processing, cybersecurity, obviously, inspection robots, forestry, which you can see as part of agriculture as well, particularly when you team that up with satellite observation. Industry 4.0, which definitely is very much at the forefront of the adoption of AI, the health industries and legal tech. So as you can see, there's no vertical that is immune from the ability of AI and data analytics to be able to improve its value delivery to customers. And just in summary, if we look over the past 3 years with CeADAR, you can see that in terms of our work that we've done in collaboration with individual companies, that if my maths is up to, that looks like 85, we've had 85 funded collaborative work programs with companies to deliver value to them. That's on a one-to-one basis. We also have a program which we call our demonstrators, which is actually a no charge offering that we have, where we develop AI technologies and then make them available to our member companies to try out at no cost with our assistance. And as you can see, a lot of SMEs and a lot of multinationals have been involved in those programs. And that's all part of the Digital Innovation Hub offering. Now, Ricardo, and today, as he's mentioned, is very much part of DIH World, but we're also involved in these other Horizon 2020 consortia, all very much focused around the concept of digital innovation hub. And you can see there that map of Europe, which shows the number of organizations like ourselves and industries that we're working with across Europe. And I think at the moment, actually, there's over 90 of those in total, which again is a great testament to the whole thrust behind the idea of the digital innovation hubs, because we are drawing on the experience and applications across Europe, and we are much stronger together in that way. So in terms of CeADAR itself, we've got a foot in both camps. We've got a foot in the world of university and also a foot in the world of business and commerce. And we see ourselves as the bridge between those two worlds. Now, we are different. We're not an academic research center. We are much more market facing. So our whole emphasis is more towards the right-hand side of this slide, where we take the very latest in knowledge and development and bring it to business to deliver value to industry. And you're probably familiar with the technology readiness level scale, which you see there at the bottom of the slide, which shows that CeADAR is focused on what we call the higher technology readiness levels. So where we take new knowledge and bring it to business for their value creation. So we'll talk a little bit about the services that CeADAR offers. Now, this is all part of the Digital Innovation Hub package. And what you're hearing for us, although we've developed this a lot more, and because CeADAR has been a digital innovation hub for 8 years, we have a certain maturity in these various vectors of value that we bring to our companies and to the community of DIHs in general. So I'll just talk just briefly about some of these, but as I say, they're very similar to what other DIHs will be doing. The first aspect of that is the advisory services that we give to companies. We're a not-for-profit organization. We're funded obviously by the government here in Ireland to help companies with a presence in Ireland get full advantage from AI and analytics. The other advantage that we bring to the party is that we're not pushing any particular proprietary technology solution. We're independent. And so we hope that when companies come to us looking for technological and business advice about the application of AI and analytics, they can be assured that we've not got a hidden agenda. We are telling it as it is. So therefore, that's part of the advisory services, and that is something which is in great demand for CeADAR. We develop bespoke solutions for companies, and I'll talk a little bit about some examples from Industry 4.0 in a moment. The other aspect of what we do, and it is a large part of it, is the so-called AI demonstrator program. Now, for us, a demonstrator is a technology offering which is available. We've got over 60 of these so-called demonstrators now available to all companies at no charge, to allow companies to very rapidly test out the various techniques and technologies that are available in the armory of AI and analytics. And it's been a great success for us because it really reduces the barriers to entry for companies to be able to deploy these solutions. And we develop these demonstrators based on suggestions that come into us from our industry member problems. So it's not that we invent toy examples. These are genuine challenges that our member companies are facing in their day-to-day operations. They propose them to us, and we develop a solution over a period of 6 months. We assign a team to these, and the current ones and the previously existing ones are all available, and they're demonstrated on our website, along with a little video which shows you actually what the system is capable of doing. And I'll just plug that in a couple of weeks' time, we're actually releasing the next tranche of our current AI demonstrators, where we've just finished 5 of them, which will be coming off the production line, as I say, in a week or two's time. And if anyone is interested, actually, if you go to our website, you'll see that there's a link there to that webinar where we'll be demonstrating those. And we have a lot of other ones that are available. I'm sure there's no company here that won't find an example that'll be of some use. And they're meant to be usable by non-experts in the area as well. So we've really stressed to make them usable and easy to use. The other aspect of the Digital Innovation Hub is bringing companies together in Ireland into the community of DIHs and other SMEs across Europe. I see we're getting a lot of dings here. A lot of people are coming in and joining now. So one of the big aspects of what we do is networking and brokerage, not only within Ireland, but within Europe generally. So we get requests from companies in Ireland to be put in touch with other companies that might be of use to them, both here in Ireland and abroad as well. So that relies very much on us having very strong connections across Europe and within the state here too. The other area that we offer are collaborations. Now you can see, apparently this little picture is a medieval gin still of lots of people working together to make the best gin possible. Well, maybe we're not making gin, but we're making something a lot more valuable and even more tasty as well. So we work in collaboration with companies. We form collaborations of ourselves, multinationals and SMEs, to apply for national funding here and also European funding, and to work together on projects that are self-funded by companies too. And the very final little icon there on that slide deck are company workshops. This is something which is a very popular offering from CeADAR, where we actually work with companies over a series of workshops to actually really crystallize the challenges that they're facing and where AI can help out in that. So if I show you the next set of services that we as a Digital Innovation Hub offer, there's executive and technology training. We have a very popular apprenticeships program where we've had 20 SMEs, all Enterprise Ireland clients, on a program that's funded by Enterprise Ireland. So each one of these companies gets for a year, they get a person who has been selected by CeADAR, who has already got a master's degree in AI and analytics, and works with us and the company on the company premises for a year to really inject AI and analytics DNA into the everyday operations of the company and their products and services. One of the other services that CeADAR offers, and it has been developed over the past year, is our AI benchmarking. So this is to help companies in their journey to AI maturity. And I know Sue was talking about that as being one of the challenges that companies face. So we offer a structured program where we take companies through the journey and we work with them step by step to get them to become much more sophisticated users of AI and analytics, and to help in their digitalization of their whole operation. Helping companies find funding is another important aspect of what CeADAR as a DIH is doing. And we often work with companies to bid for funding. And we have a very developed program now of spin-out companies in CeADAR. We've got 5 companies who are investor funded already within CeADAR itself, moving through a maturity stage with us and leveraging our AI expertise to actually make their offering more investor ready. Obviously, we work within Horizon Europe and Horizon 2020, and we will soon be commissioning our high performance computer. This is a very powerful machine that we're co-building with Dell Computer Company, and we will be making this facility available, obviously not only to our member companies, but also to more generally as well in the community. So that really gives a sample of really what a DIH is all about, and the services that a DIH, Digital Innovation Hub, delivers into the local ecosystem, obviously for the benefit of all. Now what I wanted to do is just very briefly take a quick run through some of the projects that we have been undertaking with our industry partners, specifically with an Industry 4.0 slant to it. So one of the areas in Industry 4.0 that is obviously very important is robotics. We've got a very nice project with a company based here in Ireland that has a vertically climbing robot. You can see it there in one example, climbing over the surface or the fuselage rather of an airliner. The machine is able to actually adhere to vertical surfaces, and with its cameras on board is able to take very detailed pictures of the actual fuselage, in that case of the aircraft, to look for cracks, fissures, faults in the structure. And now by the same token, the area that we are specifically addressing is in very large grain silos of the sort that you see in the Canadian prairies. So what happens with that is that the little robot not only scales the outside of the silo, but also the inside as well. We form a digital twin of the structure and automatically identify the various faults, failings, cracks, fissures, welding problems that are in the structure. So it is a much safer way of being able to analyze these very, very large structures rather than actually have a person having to clamber up and do a visual inspection himself. So this robot can do that for them. And we're obviously going to see much more of this in future, because this robot can also scale buildings itself and also mechanical structures. So it's a very exciting area to be in. One of the areas that we've been working in now for some time is in energy production, particularly as part of Industry 4.0. Predictive maintenance is very much part of the canon of Industry 4.0, and that is where we can predict the failures of processes of machinery months in advance of the actual failure taking place. And the center, CeADAR itself, has actually built up huge experience in being able to detect the imminent failures of wind turbines. For instance, we've worked with various multinationals and Irish SMEs in this area. And of course, that is equally applicable to production processes as well. So much better to be able to predict that something is going to fail weeks in advance and be able to do something elegantly in the here and now to prevent that failure happening in the future. Obviously, in Industry 4.0, the consumption of energy and the minimization of it is very important for factories. And so we're involved actually in minimizing the energy consumption in factories. And we've got various ways of doing it. One of the ones that has actually proved to be actually very, very useful and producing great results is reinforcement learning applied to that. And we're working with several large data centers, both here and in Scandinavia as well, to reduce their energy consumption. And of course, the other aspect of this work is in the prediction of the power output of those turbines as well. So just dwelling for a moment on the preventative maintenance side, we have another project which is just finished and successfully so as well, looking at predicting the failures of the large pumps and valves that sit on the ocean floor and pump oil and gas from under the ocean on shore. And this is a very, very costly business, as you can imagine, and any failures there can be awfully catastrophic. And so with the work that we've done with an Irish SME based in Galway, we were able, with great precision, to be able to predict failures in their processes. One other area which you might feel is a little bit unusual is natural language processing. Now that is an area that has really increased in importance for CeADAR over the last 2 years, 2 to 3 years, particularly in the analysis of legal documents. But what we're seeing now is that with the expertise that we've developed in this area, that the industry process logs, which are often textual documents, are actually very amenable to the automated processing of those logs. And that is, again, another piece of work that Ricardo is involved in. So, and I've only got 2 more slides, you'll be glad to know. Process visualization and simulation. Again, this is one of these demonstrator projects that I was telling you about, just to give you an example of it, that we take the system event logs from the processes. We have developed a tool which automatically discovers the process and develops this web diagram, as you can see. And then the tool allows the user to be able to experiment with the process to be able to optimize it. And the tool gives an awful lot of what-if scenarios to allow you to optimize your processes. And finally, then, if we look at the work that we're doing, applying AI to production lines, obviously ones that you'd be very familiar with, although this is a bit of an image captured from the web here, is computer vision inspection for quality assurance. We do this with several companies. Again, it's very commercially sensitive, so I can't really talk about it in any detail, but we've developed the skills and expertise to be able to apply computer vision monitoring in QA, and obviously applying machine learning to optimize production processes. And one area that we're working in as well is using machine learning in the food industry for sensory panels. So this is whenever a company develops a new or innovative food product or offering, typically what you need to do then is get a panel of people who are skilled in tasting, a bit like noses in wine. But in this case, it's actually a tasting panel who are able to predict what the general public is going to feel about this particular new product innovation. And what we're doing is using machine learning to actually supplement the human efforts in that. The other area is we've got a very large project with a multinational here in Ireland, is using machine and reinforcement learning, again, for quality assessment of electronic subsystems, ultimately before they're put together into the final assembly, again, to reduce the number of rejects. Factory energy consumption, I mentioned predictive maintenance, and in the supply chain as well, which is very important for Industry 4.0, not only the optimization of supply chain, but also the implementation of blockchain in that. And that's the final area that we have a lot of experience working with some of the major players here in developing blockchain solutions for moving physical assets around the globe. So that's it from me. I hope that at least has given you an appreciation of what a digital innovation hub is in the European context, and the way we've imagined a digital innovation hub here in Ireland, and as well introduced you to some of the examples where AI and machine learning are making a big impact in Industry 4.0. So I'll hand you back now to Ricardo, and thank you for the opportunity of talking about CeADAR.
Thanks to you, Edward. Great presentation. It has been very clear, at least for me, but obviously I'm a little bit biased because I work in CeADAR, so that doesn't count, right? But I think, people might have some questions now. I'm not sure. Otherwise, we can take them later. You can ask about the specific projects that Edward presented as well. There are more projects in the manufacturing sector and even in other sectors that somehow relate to the manufacturing area, right, Edward? So at the end of the day, we're here to answer your questions. So do anyone has any immediate question now for Edward about, for example, CeADAR, how we operate, or the projects themselves? While you're thinking, I would say one thing as well. There's a lot of ding, ding, ding here, as I was saying, people joining. it looks like it's better, to start the event at 9:30 rather than, at 9. People are still in bed or wherever. But I think it will be good, if people, whoever wants, just put, their name and then in between brackets their organization. Because if you want to network, it's always, good to know who is in there, and maybe you can either do it, publicly or in a private message. Because at the end of the day, this event is supposed, to network people. Okay. So that's if you want, obviously. And I'm saying that, and I'm not doing that myself, but I will do it now. Okay. Anyway, so any questions for Edward there? And I don't think it's fair me asking a question for Edward, because I know everything about Edward, right?
Yeah, that might be a bit of a tricky question, Ricardo, and I'd have to speak to you severely afterwards for asking it. No, so that's
exactly.
Yeah.
Otherwise, as I said, you can take the opportunity if you want the key committee there in the breakout sessions there with Edward, just to ask about the center, if you want to collaborate with us or see the benefits. Okay. Okay, fantastico. So now we're good on time, right? 3 minutes now to Brendan. So let's move on there with Brendan Seppert. And as I was saying, he's the CEO of Smart Factory, which is a very innovative SME in the area of IoT and now analytics. So Brendan, you're there in your nice chair. Whenever you want, screen is yours there.
Thanks very much, Ricardo. I'll just share my screen here now. Okay. Good morning, everybody. Thanks, Ricardo. Thanks, Edward, and thanks, Sue, for the opportunity to present our perception of AI and how it can be used in terms of manufacturing. And I'm going to talk a little bit about a specific use case. So it's a real life project. It's one of the leading manufacturing, consumer goods manufacturing companies. But before I go into that, I'm just going to take a couple of slides just to talk a little bit about digital transformation and what we know, I suppose, based on the last number of years of work with manufacturing companies, is an awful lot of companies are struggling with digital transformation. And I choose this slide because I suppose there's the laggards and there's the leaders, and it's amazing actually how many companies, and as Sue referenced it, people are unsure what to do. They're unsure where to begin. There's an awful lot of hype, and there's an awful lot of nonsense out there, and an awful lot of companies talking about technology as opposed to problems. So part of, I suppose for us, part of the journey when we get on a digital transformation project is to try and help companies create a blueprint of, what's the North Star, what does good look like, and then how to get there. And we have some views around that, to break it down into quantifiable chunks and kind of make a stepping stone, if you like, of what that journey would look like. And part of the problem, I suppose, is what is digital transformation? And digital transformation is an awful lot of different things to different people. But I think what has happened over the last number of years with digital transformation and the talk around Industry 4 and smart manufacturing, all this kind of stuff, is the language that's being used is frightening people, and it's alienating people, and it's like rabbits in a headlight. People are going, oh my God, there's so much information coming at me, I don't know what to do. Cyber physical systems, digital twins, all of this kind of terminology, and it's leading to, again, there's this kind of the hype, and then I suppose the reality. Yeah, everybody has heard about this wonderful stuff that can be done, and now it's like, well, now where are we? And they're stuck in this trough of disillusionment, if you like, of we're not sure where to go.
Brendan, are you sharing any slides now?
I'm sharing my slides.
We cannot see them. I was just waiting until you were finishing the
I'm sorry.
introduction there.
Is that better?
Yeah, we see all of these strange bodies there. Yeah.
Okay. So this was the slide that I was talking to. Apologies for that. So I suppose this is our perception of the laggards and the leaders in terms of digital transformation, and companies struggling to even get going, you know, where to begin. Okay, and part of it, I suppose, is this. I think this slide sums it up well around this whole Tower of Babel, if you like, of terminology, cyber physical systems, digital twins. There's so much language out there, and an awful lot of the language that's being used is not language that's familiar to manufacturing companies. You know, they're used to production schedules and ERP systems and whatever. So there's a big gap between, you know, what this is kind of the language around smart manufacturing and day-to-day manufacturing operations. And then again, this slide here is around the Gartner hype cycle. And you know, there's all this fantastic technology that's coming, but for me and for us over the last couple of years, all of the area around AI and IoT, smart manufacturing, there's this feeling of disillusionment. It's like we were promised this wonderful stuff, and it was meant to be easy, and now, well, we don't know where to begin. And there's a general feeling, I think, of confusion, and that's part of, I suppose, of where we try to help, and we try to help companies to find a kind of a blueprint, a stepping stone of where are you now and where do you want to get to. Our biggest challenge is Excel, and so many companies are running their manufacturing processes on Excel. So if we think of you know, what is digital transformation, and digital transformation is a lot of different things to different companies. But for a lot of companies, it's simply getting away from very manual processes. We have world-class companies that are spending hours. We did a study for one manufacturing company, and their process engineers, you know, really bright, well-educated engineers, spending 14 hours a week filling out paper forms, creating pivot charts and putting it up. And they were so busy, they didn't have time to actually look at the data. They were too busy trying to get to the data. So, you know, the whole idea of interconnecting, again, Sue mentioned this, you know, some companies are well evolved in this process, some companies aren't. So how do you make your infrastructure ready to bring all of this data together? And then for us, the most important thing is if you have real-time data that you can take action on, that you can look at what's happening now and make decisions now based on what's going on in your process. And that data can allow then, you know, continuous improvement. And this is, you know, this is the why, if you like, you know, so why are we doing any of this anyway? It's to make the process better, to make the process more efficient. And then obviously you can start to feed that back in. So if you see problems and see areas for opportunity, then feed that back into design and improve your process. And a big thing, and we see this is becoming almost on a weekly basis now, we're having conversations around sustainability and the use of the resources, and not just the use of energy, but the use of water, and you know, resources that are considered free resources, but people are becoming much more aware of the environment and of their interaction with the environment. So I suppose from a digital transformation point of view, you know, why does it matter? Okay, so and at the end of the day, it comes down to making manufacturing companies more competitive. Okay, with better efficiency, better quality, you know, more agile, reducing defects. And one of the things that we know is there's a whole opportunity. Even I mentioned, you know, some of the companies that we're doing work with are Shingo Prize winners, have, you know, fantastic track records in terms of operational excellence. And even working with them, they're able to achieve greater than 10% increases in efficiency. So there's massive opportunities, and I think even the 30%. We have one medical device company that increased their output. They thought they were out of capacity, and they were going to build an extension and buy more machines and put it into it. And we put data collection systems on those, and they managed to increase their output by more than 40%. So the opportunity is huge. So that's a little bit around digital transformation. So now to talk about today's topic, which is around AI and digital transformation. And the company here, it's Danone Baby Nutrition. And I want to present the use case of a real life example of how we started from zero. So a company with a really strong operational excellence culture, having lots of data, but in all these different silos. So we're going to talk a little bit about what were the prerequisites for this solution. How did Danone begin that journey? Where are they now, and where do they want to go? Okay. The whole area of connectivity and data integrity, really important. Security and scalability, how do you make it robust? How do you, cyber physical and cyber security threats are getting, more significant. So how do you do it with that point of view? And then when we have all of this data, have we got the data in the right data format that we can start to apply data analytics to that? And I'll talk a little bit about the work we've done with CeADAR and how we've managed to get deeper insights because we've got good data to start with. Now, what can that data start to show us? And then what's going to come next? Okay, so we've already put this project has been going on for some time now. We already have the first 2 phases of the project completed, and now the company are really, really hungry for more. So they're saying, can we use data analytics to start predicting failures and whatever? So I'll talk a little bit about that. So that's I'm going to spend the next 10 or 15 minutes just talking about these items. So the first was the prerequisites. So Danone, world-class company, manufacturing sites all around the globe, fantastic culture of operational excellence, and particularly this site. This site is based in Cork in Ireland, and they're considered one of the best spray dryer operators within the Danone group. So they're already up there at a very high standard. They have a fantastic culture of looking at data and making decisions from data. But the data is in so many different systems. So in their control room of their spray dryer, there's about 30 different monitors showing 30 different systems to say, well, how is everything? What systems do I have to look at? So I suppose the underlying requirement here was that whatever we were going to do here was going to support the already good systems that they have in place. Okay. Some of the equipment is new. Some of the equipment is 20 years old. So how do you put in a system that's able to deal with legacy systems without spending, a huge amount of money? How can you start small and scale it into something bigger for the future? Obviously, cybersecurity and data integrity, I could spend a whole day just talking about those. So that's really important in any of these projects. And then when you have this good data, how can you've got the very linear data, is it good, is it bad, the reds and the greens. But now how can you drill into that data and start to find real insights around why does product A behave differently to product B? Okay, so this is what they wanted. So they were very clear about the objective, and the way we approached it was, okay, let's start small, let's start with a pilot, and then scale it from there. Okay, this is just a slide I want to present, and Sue mentioned this in her presentation as well. This is from the RWTH in Aachen University, and we've adapted it. We've kind of stolen their idea, and we've added in two more key elements that I think are really important before you start digitalization as a journey at all. And that's about where are you starting from? And what I see, a lot of Irish manufacturing companies, we're doing projects around the world at the moment, but a lot of Irish manufacturing companies have a very strong culture of operational excellence. So they're starting at a good base. They've been on Enterprise Ireland and IDA have been really strong at enforcing this kind of lean excellence and all of these kind of stepping stones to drive operational excellence. So lots of companies are in a good place around operational excellence, or at least know the value of it. And now they're going, well, how do we get from here? How do we bring in digitalization? And there's two aspects then to what is digitalization going to do, and one is knowing why something is happening. Firstly, I suppose, is knowing what is happening, but clearly the objective then is to know why it's happening. And then once you know why something is happening, can we start to use AI and machine learning tools to know what will happen based on the history and the parameters of what has happened over the last period of time? Can we start to predict? And then obviously the future step then is to look at, well, can we make these systems so clever that we can actually start to feed back into the PLCs and have the PLCs learn and improve. And that's part of this project that we're doing with Danone, is they've built a digital twin of, they had a before digital twin was a term, a sexy term, if you like. They had a computer model. They've had a computer model in their research center in the Netherlands for years. But the model didn't match the actual large scale system in Cork. And now what we're able to do is we've got so much data that we're able to feed in, that we're able to feed data from our process, from our historian, back into their digital twin. And now we're going live, hopefully in the next few weeks, with a much more reliable digital twin. So this idea of this autonomous system is absolutely achievable. But the barrier with a lot of this digitalization for a lot of companies is, and again, Sue mentioned this, is do you have the right culture? Are your leadership supporting? Do they know, again, they might be experts and world-class manufacturing companies, but why are they doing this? What problems, I suppose, are we trying to solve? And that, to me, is this first step of this digital transformation journey, is to ask the why. Why are we doing this at all? What problems are we trying to solve? And if we solve those problems, what business value can we create? And to me, that's crucial. If we're just solving problems to show off cool wireless sensors and IoT technology, then it's an academic project. But if we can actually show real business value and get engagement from all of the people involved, now you can actually start to get real momentum behind the project. And again, this was mentioned by Sue earlier, is your organization change? People are nervous about this. And what we see is an awful lot of companies are talking about the technology, and they're getting caught up on, should it be X? Should it be, Windows versus Linux? Should it be, supplier A versus supplier B? To me, that doesn't matter. It shouldn't even be relevant. The technology is more than well proven. We were installing data collection systems 20 years ago. This is not rocket science for I think for people that know what to do. The problem I see is that people are too caught up on the technology and don't really have a clear focus on the strategy and the why. Okay, so what we have in the Danone case is an industrial spray dryer, and in very simple terms, a spray dryer is a chamber, like a cyclone, where you spray in a liquid formulation, a concentrate, at very, very high pressure with hot air, basically, and the product that comes out. So it looks like a fog inside in the chamber, and what comes out the bottom is baby nutrition. In this case, there's obviously lots of different processes use spray drying process. So this particular process is one of the largest industrial spray dryers globally. It's huge. It runs at the first system that we've done, it runs up to 15 tons an hour. So the first phase of the project was to install our data acquisition system, to connect into and all of these sensors and PLCs, and they already had SCADA systems on site. They already had databases. They already had historians, but the data was all in various different silos. They had energy meters. They had steam meters. They had so there was an awful lot of data already, but all in separate silos. And what we did was we designed an infrastructure to allow us to bring all of that data into a centralized system. Okay. Their energy consumption is over 15 million euros a year. So the opportunity in terms of cost savings are really significant. Within our model, there's a huge number of process variables, thousands of process variables on site. We've selected 1,200 process variables as the variables that we believe are relevant in terms of understanding the energy usage, the utilities, the water, the compressed air, etc. But then also understanding the process, flow rates, densities, etc. So we can really start to analyze what is going on in the process and how do these variations in these process variables affect the outcome from an energy point of view. So we started out, I think since July of last year, we've about 6 million data points. So we've got a really good, and we put a huge amount of effort into the building of the working with the team on site, who are a very, very knowledgeable team. We put a huge amount of effort into making sure that the data that we were bringing in was useful data and clean data. So with the objective that when we start to apply data analytics and advanced data analytics to it, it needed as little work as possible. And that was the objective then of phase 2 is, can we use the data from our wireless sensors and gateways and all these different collectors around the site? Can we use that data with AI and machine learning tools to reduce energy consumption? And that's what we're going to tell you a little bit more about. So first, a little bit about the system architecture. So again, huge site, hundreds of controllers and sensors and all the rest. In very simple terms, we've got 2 spray dryers on the site, which were already connected, which were already in an OT network. So we brought all of that data and we put a separate historian in. And again, this all talks about cloud and taking data off the premise. Our view is, if you want high-speed data, we can analyze data. We've got examples with companies where we're capturing 1,200 data points a second. So if we want to really understand variations in a process, our view is that you need a on-site physical historian to get that data. What you do with it afterwards and go to the cloud is fine, but to be able to bring that data reliably and securely in, we've put in a historian on site. OPC, again, we believe is the standard for the future in terms of connectivity. So again, for people that don't know, it's a standard that allows us to talk to Siemens and Mitsubishi and Omron, any of the various different controllers out there, Schneider electricity meters, Endress and Hauser. So we're looking at steam meters and gas meters and all these things, all using the same technology. In some cases, this infrastructure was in place. In some cases, the sensors were there and the meters were there, but there was no way of connecting to them. So we put in a series of data collectors, we call them gateways, and we put those dotted around the site, and then we connected in the sensors or the meters into those data collectors. And then in some parts of the site where access was really difficult or the cost of running in network cables was really expensive, we put in wireless sensors. And that allows us to very quickly put the infrastructure in to capture those, all of that data, maybe in hard to reach areas. So all of the data comes into a historian. We analyze it in our application called WAPS, and then often we have to look at, well, what is the product? We need to know what product is being made. We need to know, warehouse management systems. So there's all these different database, if you like, relationships that we have to bring together to understand. Here we've got the live data from the process, and now we've got various different recipes or formulations, whatever. How do they come together? Ultimately, everything ends up in dashboards, and I'll show you some examples of the types of dashboards. So what people want to be able to see is this, again, the concept of, we call it the 1-6-10 rule, that I can look at a dashboard and in 1 second, I can tell, am I in control? In 6 seconds, I can tell what's not in control. And in 10 seconds, I should be able to look at the dashboard and know what's been done about it. Okay, and that's really important in terms of how the data is presented. We've seen some examples of dashboards, and there's so much information, it's overwhelming. It's like looking at an Excel spreadsheet of a finance company. It's just, you know, mass amount of data, and you can't really see. So our philosophy is very minimalistic in terms of how we get the data presented to the different users that are looking at it, and it's contextualized. So a person in operations, a person in the warehouse, a person in maybe maintenance, whatever, are all seeing different information depending on what they want to do. Ultimately, all of our data ends up in Power BI because most manufacturing companies that we're working with are using Power BI. So we're bringing that data into Power BI for them to do their own. Maybe the finance guy wants to look at, you know, losses or waste or scrap or material wastage, whatever. And then finally, if we've managed to do a good job, and this was part of the experiment with this digital innovation project, was if we're able to do a good job with how we get the data, can we then use that data in a machine learning with machine learning tools to get even deeper insights into it? And this is what we've done in this case, is looking at analyzing the different products. So they had a target of, you know, they knew how much energy they used per year. They knew how many tons of product they used per year. But now, can we dig deeper and use machine learning to say, well, every time this product is run, here's how much energy is used. And that's what we've managed to achieve. So here's an example of a dashboard that we've created. And this is the spray dryer. And what we're plotting here is the real-time state of the process. So the process running from 7 o'clock in the morning until 7 o'clock in the evening. Hugely reliable process, runs, you know, really high efficiency, but very high energy consumption. So we've analyzed all of the electricity consumption, all of the gas consumption, all of the steam consumption. We brought all of that together to be a energy amount. And then we're looking at the throughput. So that at the moment, the process here was running at over 14 tons an hour. So what we're showing here is how many tons, how many kilowatts of energy are being used per ton of product produced. Okay, and that's one of the metrics that we've now, what we've done with CeADAR is we've analyzed all the different products that they make, and we're able to say, oh, look, this product takes much more energy than this product. Why is that? So what we've been able to do, if I just step back to the previous slide, is we've now been able to set targets by product. And this is the starting point, if you like. So every time they make this product, leadership now know this is the target that the system should be running at. And if they're on track, if they're using less energy than the target, then it's green, it's good. So at a glance, these screens now are in the canteen or in the reception or all across the site. So very visual way of indicating, is the process running at its optimum? And rather than waiting for, you know, the end of the month results and go, oh, we used more energy than we should have again. Now they're able to see live, and phone calls are happening and texts are happening saying, you know, why is our energy up? And they've already seen significant benefits in being able to visualize the data like this. So working with, so when we gathered all of the data into the historian, then we worked with Lauren and Ricardo in CeADAR to look at that data. And that was the objective of the first phase of the project is, can we really, is this just theoretical, but can we really take that data out of the historian and do detailed analytics of it using different analytics tools? And I'm a mechanical engineer, so data science is not my expertise. So, but Lauren can explain, if anybody has any questions at the end, Lauren can explain about the model that she's built. And she's done amazing work looking at how all of the data, you know, I was amazed at, you know, we were able to give her such a huge volume of data. And really within a couple of weeks, she was able to break that data down into the different products and really see patterns that you just couldn't predict with our linear sort of analytics. So the capability of the system in terms of being able to use that raw data from the historian. Historian data is like per second data, you know, what's the temperature now, what's the temperature a second later, that's time series data. But we've demonstrated that we can use the tools that CeADAR have to be able to really start to find variations in those processes. And now we have set targets for these products. Okay, so the next step for the customer is they're really excited now about this capability, and they're saying, well, could we use AI and machine learning to analyze other elements of the process, the flows of air through the spray dryer, the temperatures, the pressure drops, all of those things. Could we use AI to predict when a failure is going to happen? They get chokes in the drum, in the chamber, and it's a really significant issue when that happens. Could we look at compressed air usage and find a background level, and then predict that if a diaphragm bursts or a valve fails, that we could create an alert saying, hang on, you're gone above your normal threshold values. So there's a huge amount. To me, we've only just scratched the surface here. Now we have set targets for every product. And this is daily management. They're looking at these targets and saying, can we make it better? Can we, we're going to start to reduce by a certain percentage the energy consumption, but we're also looking to say, okay, what more could it do? What is it about these formulations that's causing? We know, I can tell you why this particular product takes more energy, and part of it is to do with the formulation. But what are the other environmental factors in terms of outside conditions, etc., that affect energy usage? Okay, I'm aware my time is running out. I could talk for a long time, so I'll just quickly give some quick overview. So again, looking at some of the other information that we've managed to capture. This is looking at the hourly output from the process. And again, when are you good? When is, again, visual controls, when is it running properly? Why did I not hit my targets in this area? Again, using the data to drive those decisions. Utility monitoring. We started out with monitoring the energy into the spray dryer. We now have the whole site connected. We have every water meter, every compressed air, nitrogen, all of that now coming back into a centralized system. And again, the next steps will be to try and look at what's happening around the process that these consumption rates are changing. Okay, compressed air usage. Again, we talk about digital transformation and workflows. This company we're spending, and they have fantastic processes in place around making sure their standards and everything has been operated at the same level. But it was all based on paper forms or Excel sheets. And now we've put in automated systems for that to say, okay, safety, how's your safety, how's your quality, all of these different this is what they call a shift report. Again, digitalizing that, making not only, there's two things happen now. Firstly, you make it easier for the person to enter the data. But secondly, you now are capturing all of this data in a format that's easy to analyze afterwards. And then you can say, well, so we've discovered that of the 4 cycle shifts, one of the shifts we're doing a changeover differently than the other shifts. Could have been happening for years, but you start to see from the data that, could be behavior, could be process, could be different tanks, whatever. But you start to analyze data and see data that information that was never visible before. So finally, next steps. So again, fantastic feedback from the customer, really excited about the amount of information that we've been able to get from them so far, looking to go much further, looking to really start to dig deeper into the data. And what we've done now is looked at part of the process on part of the systems and said, okay, here's the energy targets. We now want to expand that out across all of the products that are made on site and use AI to analyze that and say, okay, here's what the average energy usage is by product across all of the systems on the site. Could we use, like I mentioned, could we fit wireless sensors onto this drum, into the cyclone, and predict it or measure the temperature fluctuations around the spray dryer. And then could we use AI to notice by product what the fluctuations in those temperatures are, and then start to say, well, hang on, we know if this temperature here changes by X amount, there's a chance that a blockage is going to occur. If a blockage occurs, it could mean that somebody goes in there with a shovel and takes it out. It could mean shutting the plant down for hours and someone going in there with a Kango and breaking it. It is a huge issue. Doesn't happen often, but it's a huge issue when it does happen. So, could we use AI and machine learning to look at how that process, the good conditions, if you like, or the ideal conditions, and then start to create alerts when it starts to go outside those ranges. Again, I mentioned about compressed air. So they have big bag filters on the exhaust air that comes out of this huge usage of compressed air. What happens if a diaphragm bursts, if a valve bursts? It could be leaking for days and it mightn't get detected. Huge site. Could we again use machine learning algorithms to look at that usage and say, look, normally, because it's not like a flat line, it spikes on for a couple of seconds and then it goes off, spikes on again for so many minutes later. But that's normal behavior. Now can we use machine learning tools to look at that behavior and say, okay, that's normal, that's good. If I see a continuous spike or I see a spike, longer usage over time, this is so again, this would be a huge benefit if we could. And then we've fitted a vibration sensor onto one of their systems, and we're starting to, and again, a little battery powered vibration sensor. I have a little example of the type of, so these are small little devices. So could we put vibration sensors around vacuum pumps, air handling units, all of these different things, and start to predict failure? We can detect, we know what the background good conditions are, but not only do we want it to, they don't want to just predict failure or see that the alert is, they want to start to say, well, if the vibration patterns changes by a certain amount, is it a coupling issue? Is it a bearing issue? Is it a mounting issue? To actually be able to really analyze the data and not just predict the failure, but predict the type of failure, so they can take the corrective action and be ready for the changeover. Okay, so that's I've gone over my time, Ricardo. So finally, this is just a little bit of kind of an overview of us. We've got again various different modules within what we do, from medical device companies, day-by-hour type analysis, digital workflows, and that kind of thing. The relationship with CeADAR is, I guess, nearly 2 years old now. It's been fantastic. The guys are such a competent team, I think. And again, I was really surprised at how they could take what looked like to me was a big bucket of numbers and process variables, and start to really make insights and benefit from us. So we'd be happy to talk to you. We've got, I think on the call with us at the moment we have a partner in Switzerland, Solution Sync, and I think they've got some interest, particularly in the area of spray dryers and some of the companies that they've been talking to in the Swiss area as well. So back to you, Ricardo. Happy to take any questions either in the chat room now or in the chat room later, or people can message me directly.
Very good, Brendan. Yeah, you've gone over the time, but you're allowed. Don't worry about this. It has been a very interesting presentation. There has been some comments there in the chat there. I just want to mention very quickly there that Brendan and CeADAR have been, collaborating together, each other for the last 2 years, as he was saying. And then there was this opportunity, to join the DIH World project, right? Talk to them, and obviously Brendan was very much promoting the use of data science in his company, and then we are closely partnered, and it was a great opportunity now to run the experiment together in the DIH World, because we had a lot of conversations, Brendan and myself, how to do that, shape the experiment, and then we were working together, particularly myself and Lauren with Brendan and his team, and then we have done a prototype, okay, but still there's a lot of power Yeah, a lot of powerful, machine learning tools that we can use there. So we haven't done even, 10% of what we can do. So the thing is just that I'm very happy to hear, obviously, that Brendan is very happy with our collaboration. I knew that. And this is the sort of things that the DIH World Project is promoting, and CeADAR is here to help SMEs like Brendan, okay, with the AI or data science and analytics. So one thing that I would say is just, I think it was very important what you say, that companies talk about technology as opposed to problems, and that's nonsense. And this is key, because that's what we hear from all the companies, from many companies that come to us. They say, oh, let's do AI, let's do reinforcement learning, let's do blockchain. But they have to identify the problem first, Sometimes they come, they don't even know what the problem is. So that was something very good. And I know Sergio Ceballos, who is over there, was saying something about, how different companies are at different stages, industry 3.0, 4.0, 5.0, and they are talking about 6.0, right, Sergio? You were mentioning that. And then also Barry Cox was asking about, if you were talking about the ISO 72001, when you were talking about the standards there, Brendan. So maybe because we are running out of time, maybe these questions, the discussion can happen later in the Q&A or maybe in the record room. But just, to point out what was said there, okay? So have a look at the chat, Brendan, because there are other things there. Okay, well, thank you very much. It has been great. Okay.
Thanks, Ricardo. Thanks for the opportunity.
Okay, and now our final speaker is Professor Pekka Toybanan from Finland. He's a DIH like in CeADAR there in Finland. And I think he's there, right? The DIH is called the Center NS, right?
Yes, I'm here. Yes.
Oh, Jesus, that's a nice bridge there. Is that in Finland, I suppose, right?
Yeah. It's the sun is shining and it's actually quite warm.
Yeah, I don't trust you.
Okay. Can you see my slide?
Not yet.
Not yet. Okay, I shared it already, but maybe wait a moment. I will do a little trick.
Right?
Share from here and then now. How about now?
Exactly, we see it now. Yeah.
Okay, good. Okay. So my name is Pekka Toivanen, and I'm a professor at the University of Eastern Finland in School of Computing. And I have a research group here named Computational Intelligence. So I'm doing AI, artificial intelligence. I have a machine vision background, and we have also been working in cybersecurity area. And we have this DigiCenter North Savo, DigiCenter NS, here in the area with a budget of roughly 3 million euros. And we have achieved this official DIH, Digital Innovation Hub status. And many speakers here have already spoken about this industry 4.0. I just want to remind you that we are now on this framework that we had 1.0, 2.0, 3.0, and now we are here on 4.0, which means that we first of all have a little bit more complicated environment to apply the AI. We have cloud processing, we have edge processing, edge computing. Nowadays, we also talk about fog computing and even mist computing. It's a little bit funny, I know, and when I first met these terms, I smiled a little bit, but it seems that they are getting round. So this is one aspect of this whole thing. And the second aspect is that we are moving from gadget world to wearable world, and from wearable world to gadget-free world. So from wearables to wearables, and from wearables to nearables. And I'm going to talk today and present you a glimpse of some of the industrial projects, some of the manufacturing related AI applications that we have been working on. Our DigiCenter has also worked on health area. We have done and applied several applied AI in several health related projects, both at the EU level together, for example, with Philips Healthcare, and then also domestic projects. But I will now concentrate on some of the industrial projects. One simple project that we made long time ago was this dimension measurement of construction elements. And it sounds quite easy, actually. When you have small elements, it's not difficult. You don't need very sophisticated systems. But I'm sorry about the Finnish language, but I didn't have this in English, so I had to put this. But if you have large elements whose height is something like 2 to 3 meters and they are 20 to 30 meters in length, and you have to measure the dimensions and all the sub-dimensions also within an accuracy of plus minus 1 millimeter, then you need really sophisticated systems there. And we had to use epipolar geometry and 1 laser and 4 cameras, but we managed finally to get the accuracy plus minus 1 millimeter, and it became a product. Then there is another interesting area, which is this non-contact measurement of paper roughness. Paper roughness is an important property from the printability point of view. Unfortunately, when you look at the paper surface, it's not very smooth. If you magnify it with the microscope, this looks like something like this. Traditionally, the roughness of paper is measured so that a laboratory person comes and takes part of the paper, takes it to the lab, and puts a tube on it and puts pressurized air, and then measures how much air is coming out. And the more air is coming, the rougher the paper, and so on. And the idea was, the question actually was that, is it possible to measure the roughness of the paper directly at the paper machine without touching the paper? And the first problem is that it's traveling 120 kilometers per hour, and then it's vibrating. So how do you take an image? Because you need to take an image to get the surface of the paper. And to get an approximation of the surface of the paper. And if you get that, then you can start calculating something. And we managed to do it with the lasers. We had to buy nano lasers, which cost something like 50 to 60,000 euros. And then we took derivative images and we created new mathematical algorithms to get the real surface. And then we calculated some image transformations. But we managed to classify the paper samples in the same order as the industry standard does. And this also became a product. So there is an online product at the moment and also an offline product. And here you can see lightweight coated paper of 3 different roughness classes. LWC paper is the one that we are using in the copy machines. So it's very widely used paper. Here you can see the setup actually. So we took derivative images, then we used some mathematics and so on to reconstruct the surface. And when we had the surface, then we used some distance transforms to calculate the rest. But it was quite complicated and cost a lot of money, and also took, but we were happy to solve it. And here you can see, here are some results. So the ordering of the different roughness paper classes is the same as in the industry standard. Of course, you can always argue that does the industry standard give the right ordering for the paper samples? Some people think that it does not, but anyway, we did it that way. Then here is one simple case. Customers, when they buy ovens to their houses, they would like to have such ovens that have similar tiles, or at least somehow similar looking tiles. And if there are defects, then the tile defects should match to each other somehow. And it was a very typical project, because there was one company who had tried to solve it using gray level cameras, just black and white cameras, and it failed. And then we went there and said that let's use color cameras and let's use some AI to classify these defects. And it was done. Then let's go into a little bit more complicated cases. Here we have classification of wood pieces based on knot classes. There are different kinds of knots on wood, and they are classified into 1, 2, 3, 4, 9 classes or something like that. And the first idea you might get is, of course, that let's make a mathematical model of all those different classes. But unfortunately, there is variation inside each class so much that it's practically impossible to make a mathematical model for those not classes. So the only way to solve this is to use a neural network, to teach the neural network using unsupervised learning. And or of course, it can also be supervised learning, that you tell that this belongs to that class and so on. This was done before these convolutional neural networks. So we used some features, they are calculated, some features which were inserted into the neural networks. But it was solved, and as a consequence, a couple of guys were kicked out from the company, and they replaced the guys with the machine vision approach. But really, it's impossible to model them, so you need to use neural networks. Then you can use imaging, even spectral imaging, in some very unexpected ways. Here is a greenhouse with cucumbers. And the question was that, would it be possible to see the welfare of the cucumber somehow before you've seen it with your own eyes? I mean, if there is a shortage of water, or if there's a shortage of nutrients, and the cucumber starts to feel ill and finally will die, can this shortage be seen from the cucumber before you see it with your own eye? And for this purpose, a spectral camera was adopted, and some tests were made. And astonishingly, the result was such that, yes, it is possible to see whether it gets enough water and nutrients. The human eye sees nothing, there's no problem, but the camera sees it. And I'm not an expert in plants really, but I would assume that if it works for cucumber, why wouldn't it work also for others? And the world is full of greenhouses, so I think this could be a good business for somebody to make a product out of it. Then defects and knots detection on wood surfaces. The problem was that we have this kind of pieces of wood with a lot of defects, not only knots, but also other kinds of defects. And the company wanted that these defects should be localized, found out where they are, and they should be classified also, so that we know what kind of defects there are. And we used some convolutional neural networks, quite large ones. We bought even a supercomputer here, and thanks to the corona, it came 5.5 months late. And when it came to our laboratory, it didn't work. Our experts had to fight with it for 2 weeks to make it run. So it was amazing. Almost 6 or 7 months delay in the starting. But anyway, we utilized large convolutional neural networks, and we achieved an detection accuracy of 99% and an average accuracy for each class. The defects were classified into different classes, and we achieved an average accuracy for each class of 86%. So this was the result. And our system is applicable to wood, metal, glass, and plastic. And it's quite a generic system. You can easily teach it to classify any defects on any surfaces. And there are 2 modes. You can either make it draw a bounding rectangle when it finds a defect, or it can directly find the relevant edges of the defect, like here with the red color. This was done for one Finnish company, and here are some other results. It can find different kinds of defects of different shapes, of different sizes, and so on. And we have tested it also not only with wood, but with other materials also, and it works because it's generic system. Then there was one interesting project, which was the 3D reconstruction of textureless objects. Or many companies would like to make the quality inspection in the digital world with a digital twin, so to speak. And for that purpose, we built an imaging setup. There are some LED lights at the roof. You can control them so that you can switch them off and off, on and off as you wish. And then we have different kinds of cameras here around. And these are just images of the cameras. We took some images of this plastic artifact, and then we developed different algorithms. One with shape from shading, where you just change the illumination and you get the 3D model even with one camera. Or then you can have several cameras around and you use photometric stereo, for example. And we achieved, these are the reconstructed images, and which can then be used in quality control. And the company wants to get rid of the physical world control and start to do it in the digital, with the digital twin. And here is another part of the product. This is made of plastic or rubber, actually, which was also modeled using this 3D system. Also here, thanks to the corona, the cameras were a little bit delayed, but it was done during 2020. Then a project which sounds very easy, but it turned out to be one of the most difficult that we have ever done. It was recognition of printed text on packages. It sounds almost trivial. So what's the problem in recognizing printed text on cardboard packages of drugs or medicine? But the problem is there that there are many different ways to put the text there. Some of them are stamped, some are pressed, some are drawn with laser, some make a little holes there and some don't, and then are these dot matrix approaches also. And then the cardboard is illuminated in from different angles, and it's not straight. There are many different kinds of parameters. It turned out to be quite a difficult one. Here we can see the results that from all these 4 images, this is just pressed text. The pressed text, and you can see that there is no ink. It's just pressed on the cardboard. And from all these 4 cases, which are illuminated from different angles, our system is able to retrieve the real text, and we are able to read it automatically. Same happens here with the pressed. This is just normal pressed text, not very difficult actually. We can do it. Then we have a little bit different solution here. And we have several variations. Here is one laser printed text, which is recovered and retrieved from the 4 example images, which are illuminated from different angles. Again, here laser printed text, and you can see that the text can be retrieved using image processing methods. Here is dot matrix printed text, where the text consists of little dots. And also that has been solved, and dot matrix printed text number 2, and so on and so on. We solved these problems, and our intention is now, along some other cases, like for example this one, we are going to make a product. We are going to make a product out of this. And then the wood inspection also is going to be one product. Okay, then we have in our DigiCenter also a organization called XR Hub North Savo, which specializes in the applications of virtual reality, augmented reality, and extended reality. And we are doing at the moment some applications where instead of communication with a screen, the person would see, for example, a three-dimensional head or part of the body, which then would talk to the person. And we are using also digital twins and trying to make digital twins in some simulations. The basic area, of course, in our manufacturing part is this AI, where we have used conversational AI and chatbots. There are some nice commercial platforms on top of which you can create and build your own chatbots. And then one of the main area, which is actually both in manufacturing and in the health area, is machine vision. So imaging. We are doing also cooperation with our health companies and health research, but that's another issue. I won't go there now. It's interesting how this 3D imaging and also spectral imaging has opened the possibility to solve problems that have been unsolved in the past. We all know the possibilities of spectral imaging. And so we are doing different kinds of things. And so far, 3 spin-off companies have emerged from our research. And now it seems that there is a possibility for a 4th spin-off company. From AI point of view, I would say that there is a lot of also rubbish around AI, because the media, for example, some people in the media are talking about how AI is solving this and that, but all we know that we don't have general AI so far. So AI is basically applied to some limited areas. Maybe someday it will develop more, but it's far away at the moment, I think. So we don't have to be afraid of AI, that it would come and conquer the world. This was just a glimpse of some of the things we have been doing here, and I seem to be on time, so thank you very much. I will see if there are some questions in the chat.
Thank you very much, Pekka. It's been a very nice presentation covering different applications there, which I think, the audience would have appreciated, because I enjoyed pretty much. And it is good to know that we are kind of homologous, DIH is there, and we work in similar areas. And I have to say there that Pekka and his DIH, the DE Center NS, they are also part of the DIH work project.
Yes.
Yeah. So they just ran one of the experiments there in Finland, right, with a company there, and was very successful. Was it the one in wood? Was it? Pekka?
Excuse me.
Was it the one in the wood, vertical in wood, right? With
yes.
wood?
Yes.
Yeah, exactly.
Yeah.
Okay. So one of the things
Thank
that
you.
I want to say is on the wood, model. It was very nice that you mentioned that that it is true, that sometimes you want to use a mathematical model, for example, to identify defects, in images or in anything, or predict different things, and it's just not possible mathematically, right?
Yeah, sometimes it's not possible, although we would so much like to do it that way, but it's not possible.
Yeah, because some people just come to us as well, and they come to you and they say, oh, okay, can we do that, with all methods, physics-based methods or mathematical model methods, and then we say, the beauty of data science or AI is basically this, mapping these functions that cannot be mapped by mathematical equations. And that's a key message that you gave, to the audience there, in the difference, between what we do and the mathematical, more oriented methods. I didn't like, to hear that the staff were hired, after you developed this. But anyway, I suppose that's some of the perks, bringing AI into different industries there.
Yes.
One thing that you said, which is very good, because you gave one idea for free, right? To create a startup just to analyze cucumbers with spectral images. Well, this idea
it was kind of a free idea given to everybody.
Okay, you must have a lot of ideas there. It's a good one.
Yeah, because I would assume that if it really works for cucumber, why not for other plants?
No, yeah, totally. But I like cucumbers there. I prefer cucumbers, you know.
I'm not an expert. I don't know, but I would assume.
No, we very interesting. We only work, you know, for example, with multispectral images, you know, from satellite images and things like that. Many of these concepts obviously apply. It's just to generate the new ideas. So I have a question on your presentation, but I don't want to do all the questions myself. So do you have any questions from Pekka? And now I suppose questions for everyone now, because it's just 11:20, and you know, we have 30 minutes for questions. And if there are not that many questions, we open the breakout rooms. But I think, you know, it's nice if you ask the questions here, so don't be shy. Pekka says, yeah, I'll ask a question. Now I have more questions at the moment because I'm very interested in one thing.
I can also answer in the chat if somebody wants to ask that way.
Yeah, okay. Or to either there on how to engage with CeADAR or how we work, or to Sue on the production, you know, different challenges in production and bringing AI, or to Brendan in the interesting talk about just how to engage, you know, with us, or how to just work in this particular sector of food production there, with the top players as well. So feel free to ask any questions on the side. Okay. Okay, one question that I'm going to ask Pekka while we receive some other questions. You mentioned you're using photogrammetry there. We use that, you know, for other things as well. In the 3D model reconstruction there. Okay, so
yes.
This is a very interesting area. We work on that as well. It's challenging for certain things. I suppose, you know, you were using different cameras, right?
Yes.
Maybe one camera, but different cameras, and then you were creating the 3D model. Could you just capture actually the right scale of the 3D model with this? Do you have special cameras? Or it was or wasn't needed, you know, for this particular use case or industry?
Actually, well, I don't remember the details so well because it was, of course, made by one of my workers.
Yeah.
What I remember was that we bought some cameras which looked very good on paper, but for some reason there were some problems with the resolution. They didn't work with the best resolution. So now we are going to, our method actually gives quite good results because we use some mathematical tricks to overcome the resolution problem. But now we are buying new cameras with higher resolution. We expect to get a resolution of something like 0.1 millimeter. So because the company wants to have a very good resolution for the screw holes and this kind of things, so that the measurements will be accurate. Then we noticed that, okay, we have an imaging setup, but then we noticed that there are some handheld scanners on the market. And some of them have an accuracy of ±1 millimeter, but there was one model which had 0.1 millimeter, but it goes, at least in Finland, something like 30,000 euros.
Yeah.
We made some tests with another model, and we achieved actually quite nice results. And you could freely move it with in your hand. And I think that was quite a nice idea. It works. We are now buying this super resolution handheld scanner also, and we are very interested in seeing what kind of accuracy it will give us in practice compared to the new cameras in the imaging setup.
Yeah. But they are high-end, you know, expensive devices, obviously.
Yes.
Yeah.
Because mathematically we have done everything. We use the best algorithms and so on. So there's nothing to do in that sector. We just need better. We are now buying better cameras.
Yeah, exactly. Sometimes you're limited, you know, by the hardware. Exactly. And it was interesting because you were saying that out of this work, you're looking to create a product. Are you looking to create a spin out there from your?
Yes. We are doing. We made our DC Center project makes these proof of concepts, minimal viable products, and this kind of technological platform, so to speak. And now that we have, some of them are ready. We have presented them to the companies, and the companies want to make products out of them. And they are now applying money from special sources in Finland to get money for the product development, from the demo up to the product. And we are involved in, of course, we are a university, we don't make products ourselves, but we can assist we can assist and be part of the process.
Okay, so okay.
Yeah.
You're gonna partner with,
Yeah, only partner, yes.
Then
but then it's possible that there will be a spin-off company, and then there is a great temptation, of course, for the professor to join it. But
of course, the temptation is there. Of course, yeah. Okay, very good, Pekka.
Okay, thank you very much.
No, very interesting, honestly. So, any other questions for the speakers? I mean, I know, for example, Brendan has been mentioning, different standards here. Then Sergio Ceballos was mentioning something, making some comments. I don't know if anyone wants to say something, to add something, or even introduce, themselves to the large audience there. So, if you want to do that now, is the time. Sergio, did you want to mention anything, clarify your comment on Industry 4.0, 3.0? So
hi, Ricardo, can you hear me?
Yeah, loud.
Very good. You're pushing us on the spot there. I love it. I love it.
You wanted to be on the spot. You like it.
I really like it. Let me see if I can turn on the camera as well. Yeah, very good. No, thank you very much for the session. I thought it was excellent. And no, the comment on I really, I like the two companies' presentations, because when we are talking about this digital transformation, and then we link it to the Industry 4.0, to me is something that we've been watching from Enterprise Ireland, and as well doing the working with the Commission around Horizon 2020, FP7, and Horizon Europe now. So for the larger audience, I'm the national delegate and contact point for now the digital industry and space cluster in Ireland. And so I just put on the chat there that I couldn't agree more with some of the comments from Brendan around the confusion about the concept. So it's just to take a step back around the technology itself and the problems that the companies are facing, as opposed to, I think Pekka also mentioned it. Yes, everything now, the buzzword in Brussels is AI. So everything is AI. Before it was nanotechnologies and nanoelectronics, and let's apply this to every SME, every sector. And to me, I'm just sitting looking at it thinking, well, yes, we can do that, but we can also look at the root cause of the problems for some of the companies, the small companies, for example. And we heard Don Farms initially that brilliant presentation about, is it really, in the food sector, what they need is, let's start with the small sensors, to digitalize a little bit the industry. Or do they require, depending of the sophistication of the production line, a different thing? For food manufacturing. And then we look at in Ireland, the semiconductors sector, larger companies who they've been at it for longer, and they are very well into the concept of Industry 4.0. But it's just that level of caution that, and when the Commission comes out with a new concept now, only in February, around 5.0, they created a new unit in DG or TD. And I'm looking at it thinking, if you look at that link that I sent you there at the bottom of the page, there is a document, around 20 pages summary about what the Commission understands for the concept of 5.0, which is TC now sustainability, human-centered and resilient industry, right? And you can think, well, we spoke about that in 4.0, and that could be an extension of that. So it's just that level of confusion when we talk at the SMEs on the ground. That's, sometimes I just thought that I put out there that because we need to take a step back and look at what the company really needs. And in this particular case, yes, how can we help with AI or other areas that you guys in CeADAR are working on with the industry on the ground. So that was my piece for that, Ricardo.
Jesus, that wasn't prepared, and we got a master lecture there, for you, which is fantastic.
I'm not an academic. I'm not an academic, so I'm just telling you what we see on the ground, and just based on the two presentations from the two companies, I'm just echoing those concerns, because the academic concept, I just think, in my opinion, is moving faster than what we see on the ground.
Yeah. Even I work, with AI. Obviously, we work with AI, and I'm fed up of hearing AI everywhere. It's all about AI these days in Europe. Exactly. Just for those, just to emphasize on what you were saying, Sergio works for Enterprise Ireland, and everyone in Enterprise Ireland helps us a lot, particularly, the guys, the national contact points. Sergio is the one in manufacturing and not technology, right? It's just that you keep on changing there. I don't know.
Yeah, there's a lot of changes now for Horizon Europe. There is a lot of AI opportunities. Have a look to the draft work programs for collaborative research. The programs themselves now for digital, because as I said, the Commission was really focused on this digitalization of industry. They merged the manufacturing program with the digital program, and now it's called Digital, Industry and Space, the space part. So in there you will see a lot of opportunities for AI research and innovation for companies.
Yeah, exactly. And I suppose anyone, an SME can reach out, to you or to CeADAR, and then if you need more information about Horizon Europe and how to participate there, because there are huge opportunities now.
Yeah.
Right, particularly in the area of AI and manufacturing, they are throwing a lot of money out there. So thanks for that, Sergio. I was going to ask you one question, last question, just because I have it there. What do you think, because we have been talking about DIHs, what do you think, about the new role of DIHs? Because you know that in Europe they are actually giving more power to DIHs, and they're emphasizing the use of DIHs. So what do you think about the role of DIHs?
Well, look, probably my colleague Stephen O'Reilly, who is the real NCP, National Contact Point for ICT. I come from the industry part. I think it's good that they're giving them a lot of visibility. As you know, there's going to be a program itself for it. You have the collaborative projects, the digital innovation hubs that you are part of. And there's going to be a lot of scope and a lot of money, a lot of funding around the digital innovation hubs. So watch that space, because and that's one of the positive things of the merging the digital with the industry side, I suppose. There's going to be a parallel program on Digitalization Europe, as you know. So there's going to be Horizon Europe. So that's as much as I can say on that, because as you know, the programs are not open yet. Hopefully by the end of April, by the end of this month.
Yeah, and then we have to wait until September to submit. So no holidays this year, which is terrible. Anyway, so thank you very much, Sergio. Really appreciate that. I know Stephen, I was checking, he was there. It's the national contact, another national contact point there for different area, DIHs and IT, but he's not there anymore, right? But they support us very much, in Europe, and obviously they will support any kind of SME. So, any other questions, guys? There. I see, Alan has one session here. Sorry, one question in the chat there. Alan, do you want to open your mic, or I can actually read it here?
Hey guys, no, Alan here. Yeah, thanks very much for the great sessions today, guys. Really interesting. No, I'm just it's just more of a discussion point, really, and I think in your last discussion just there it was touched on. But I guess it's from the perspective of the SMEs who may not be kind of experts in the, they may not be experts, obviously, in a lot of the technologies that we're talking about here. So is there the opportunity, and I suppose their first point of call would be the DIH, the Digital Innovation Hub, but for them to get a kind of a comprehensive evaluation of where these different technologies can be applied to their businesses, where would we recommend their first point of call to be? If they're looking to evaluate these kind of options?
Well, I can provide a quick answer, and then I think Edward, can give his view there, right, Edward? Well, I think, for me, obviously, if any SME is confused with these new technologies, okay, they usually sometimes they go to Enterprise Ireland, and Enterprise Ireland directs them to us, okay. And the thing is just it's not that I'm overselling CeADAR or anything. It's just we are very much aware of how many technologies work, not just in the broad AI kind of the spectrum, So how IoT works, how machine learning works, how blockchain works, many of these technologies. So we usually organize a brainstorming event where we explain the different technologies, and we have other events here as well. So I think for me the DIHs are the main point of contact, and then we can actually, if let's say the SME is looking for something different, we can actually point them in the right direction as well. Edward, you want to add on that?
Well, I think that's a very good summary, Ricardo. I really can't add that much to it. Just to say, Alan, that we have a team who are specifically geared to helping companies understand AI, because I think Brendan mentioned it, and Sue as well, that it is a massively complicated buzzword soup out there, and understanding what will actually be useful and bring value to the company and how they should start their journey is a point that a lot of companies struggle with. And so we have a team of people led by Yassine and Shri, who actually work with companies just to get them to understand the landscape, and then to map out a roadmap for them that makes the best sense. And the focus is not so much on boiling the ocean, but rather in undertaking defined short-term projects that will really return a big bang for the buck invested in them, to actually get the whole process moving. And so we can help with that, and that's part of the AI and analytics maturity assessment or capability assessment. And so we're very skilled at helping companies really make sense of the terrain that they find themselves in and how they can move forward. So, the companies can contact Ricardo or myself or Yassine or Shri and Maeve as well. Actually, I noticed that in one of the chats, Maeve Garrick, who heads up our European program initiatives, she is one of the people who's got the best handle on the Evolving Horizon Europe program, which is coming up. And again, a fantastic program, 95 billion euro, but again, a very complicated terrain to navigate through. So Maeve is available as well to help us. You'll see all these names and contact email addresses on our website, or you can contact any one of us, and we'll put you in touch with the right person. So that's what I would recommend to do, even just for an initial conversation, to try to understand the landscape. And so thank you for that question. I think that was useful.
So thank you very much all for being here. I see now the nice pictures there, the nice videos. It's a pity that we didn't put it before, because it's nice, to see your faces. But one thing that I would say is just that we will send the video recording, the link to the video recording there. We will send maybe the presentations if some of the speakers agree to that. I don't have any problem. Let's see about that. And then if you are interested in particularly, talking to us, CeADAR, or talking to any one of the speakers, or anyone that you saw there, obviously drop us a line, because we are here to collaborate and to help you as well if you're an SME or a DIH as well. Okay. So look, thank you very much. And if you have any critics, please don't send it. Okay. Don't tell us. Don't tell us. Better not to. Okay. But anyway, thank you very much. I will close the event now, and have a nice day.